Okay, so more 6-2a. This one's kind of a quick one. If you've got 9y squared minus 16, you've got a binomial, you've got a minus sign in the middle. So it's fitting that it looks like it's a candidate for being the difference of two perfect squares, as long as 9y squared is a perfect square, and so is 16. Definitely 3 times 3, y times y, 4 times 4. You got perfect squares all over the place here. So all you'd have to do is say, I'm expecting the parentheses here, 3y, and the other set of parentheses, 3y, and the second term, you just do opposites. You do plus 4, and then minus 4. Okay, 3y, 3y, 4, 4, plus minus arrangement. Okay, here's another one. You got some higher powers here, like x to the 4th, but just the same, what times itself gives you x to the 4th? Well, x squared times x squared, right? You add the powers. So I've got the same pattern as the previous example, where I could say x squared times itself gives me the front term. 2 times itself gives me the last term. And in between these, I can expect a plus and then a minus. This plus minus works when you have the binomial difference of two squares. Difference means subtraction only. If you had a plus sign there, it's not going to work. Okay, alright, back to a trinomial example. Remember the pattern on this. Maybe we're going to see if there's anything common that could come out front. After that, we look and say, what's the square root of the front part? Okay, well, 5 times 5 give me 25, x to the second would multiply to give me, times itself would give me x to the 4th, so I'm going to say 5x squared, 5x squared. The last term, I'm expecting 3y to the second, because I see 9y to the 4th. This is the square root and the square root. And then what signs go in the middle? Well, because it's a plus for the middle term, I'm expecting both of these signs to be plus. Remember, in the trinomial case, it's either plus plus or it's minus minus. In the binomial case, you're looking for opposites. So plus plus, and then remember with the trinomial, you just got to check. You got to say, what about the outside inside? 5x squared times 3y squared, that would be 15x squared y squared. It would be the same thing with the inside part. So when you add 15x squared y squared, and same thing again, you get 30x squared y squared, or y squared x squared, same difference. So it does check out in the middle, and we can submit that as our answer. Okay, now let's see how we're doing for our time. Alright, we've got plenty of time here. So check out this example here. Nothing common between the three terms, so we can again say it's a trinomial. We'll try to work the pattern to say 2x times itself gives me 4x squared. 3y times itself gives me 9y squared. And I have these kind of mashed together. What's the sign that's going to go between them? Well, I look back and I see that it's a minus in front of the middle term, so I'm expecting both signs to be minuses. A little observation too, this answer, what I have written there, 2x minus 3y times itself, is right. If I push submit, this is going to be correct. But because it's the same factor repeated twice, you do also have the option of typing this in, not the way I just had it, but you could actually put an exponent of 2 here, and it communicates the same thing. I only mention that because sometimes you'll see things written like this, and you have to understand that it's actually a repeat factor of the binomial. And if you had to work the other direction, you'd have to FOIL it out to get this result, like if this were the final answer. So keep that in mind, that a power can represent the repeat factor as well. Alright, so I think we're doing pretty well with these types of problems. Let me see if I can skip and find one more weird one. I think we're good with that. That's kind of a strange one there. Let's check our time. Right, we're doing okay with time. So let's say I look at this and I say, okay, what do? I see that there's a common factor of 5 with all of these. But even more than that, because the very first term is negative, I'm going to pull out a negative 5. So if I pull out a minus 5, what I'm doing is I'm creating the right pattern for the signs. It's going to be plus, minus, plus, and what I'm hoping is it will be the right kind of like special factorization. They do give you problems once in a while that you can pull out a greatest common factor and then it won't factor any further. Kind of a mean trick while you're trying to first learn this process. But look out for that. All we can say at this point on the inside is that we've got 5y squared minus 6yx plus 9x to the second. Okay? Now, I'm writing this in here because I don't have the benefit right now of writing it down on paper or whatever for you to see. But what I notice is after I factor out the minus 5, I have this stuff left inside. The stuff in the parentheses is like one of the other questions I just did, saying, can I see there's a pattern with the front value and the last value in terms of perfect squares? Y and y, 3x and 3x. And in fact, when I do that, I am going to get the negative 6xy, or 6yx, if I FOIL it back. Okay, you can do this out on paper. You're going to see it pretty clearly. But what I'm getting at is that I'm expecting y and y, and a 3x give me what I had there, and the sign in the middle was a minus 6yx, I believe. So it has to be a minus for both these signs, and the outside inside would give you the minus 6yx or 6xy. So this should work as a final answer. Okay, so I think this kind of shows you what the section's about, but let me know if you have any questions.